This is part 4 of section 4.3. Now we're going to talk about reference angles. We already know that there is symmetry when it comes to our trig functions. We know that if we're, for example, looking at our unit circle, that our number values here and here, here and here, they are all the same except for the signs. And the signs are adjusted to which quadrant they are in. Now we're going to be able to use that sort of property for values that are other than what we have here on our unit circle. And we just need to talk about how we can figure out what our reference angle is, what we can actually calculate based on the information we have, okay? So if we have theta is an angle in standard position that is not a quadrantal angle. So as long as its vertex is at 0, 0, it's at the origin, and the terminal ray is not the x or y axis. So as long as we don't have that. Then we have what we call a reference angle that we can calculate, not really mattering what quadrant our answer, our terminal point lies in. So if our terminal point lies in quadrant 1, then our reference angle, which we're labeling theta prime, is equal to the angle. Our reference angle is always going to be an acute angle, so we'll be finding our trig values for something less than 90 degrees or less than pi over 2 if we're in radians. So if you're in quadrant 1, your reference angle is the angle itself. This is your easiest case. Okay? If your reference angle is in quadrant 2, then our reference angle is right here. Okay? So this length here is going to have the same trig values as this one here with different signs. And we can make that adjustment because we know whether our x or our y values are positive or negative in that particular quadrant. So if we want to calculate the reference angle for our theta, then what we do is, this is a straight angle here, and its measurement is either pi if you're in radians or 180 if you are in degrees. So this right here is the supplement to this angle right here. So to figure out what this is, you can either take 180 minus the angle we're interested in if you're in degrees, or pi minus that angle if you are in radians. Okay? Now, if you are in quadrant 3, your reference angle is again right here. It's to do with this side of our x-axis, just so similar to here. It's just that if we want to calculate this length right here, that angle, this angle right here is a larger value than this one. So we're just going to be subtracting in numerical orders, in the order that makes the most sense, just like we would here. Here we took our larger angle and subtracted our smaller. Here we take our larger angle and subtract the smaller. So our theta is going to be larger than 180, or theta is going to be larger than pi, depending on whether we are in radians or degrees. So we calculate the subtraction in this order to find our reference angle. Okay? Now, if we are in quadrant 4, our reference angle is right here. And to calculate this, remember, this angle is a much larger value than smaller value than going all the way around. If we went all the way around, it would be 360 degrees or 2 pi radians. So to calculate this, we subtract off the theta we are interested in. So one thing to think about here is your reference angle is always going to be the acute angle that it makes with the x-axis, wherever that is. So here, our x-axis, our terminal ray, to make it acute, we're in quadrant 1 and we use this. Our reference angle is this acute one. And then here, the acute and so on. Okay? So let's just calculate some of these. Find the reference angle for each given angle. So the first thing we need to do is to figure out whether we are in degrees or radians, okay? And then we need to figure out which quadrant these particular angles would be in, okay? Now, so we've got a unit circle that we can look at easily. 275, larger than 90, larger than 180. 275 is going to be in quadrant 4. Okay, and if we are in quadrant 4, then we take 360 and subtract away the angle we are given. So we need to do 360 minus 275 degrees on both of these, and you get that your reference angle is 85 degrees. Okay? Now, here I have negative 110 degrees. I strongly suggest that you change a negative angle into a coterminal angle that is between 0 and 360 if you're in degrees, or 0 and 2 pi if you are in radians. Is going to make it much easier to do. So how do we do this? We add 360, so negative 110 degrees. If I add 360 degrees, so basically I'm going to go all the way around the circle again, this gives me 250 degrees. Okay, so what I've just done is negative 110 degrees is coterminal with 250 degrees. So if I find the reference angle for 250 degrees, I found the reference angle for negative 110. So which quadrant is 250 in? Well, 250 is between 180 and 270, so it is in quadrant 3. And if we are in quadrant 3, then we take our angle and subtract 180 to find that reference angle. So we take our angle, which is 250, and subtract 180, and we get that our reference angle is 70 degrees. Okay, now 5 pi over 6. So we are now in radians. Where is 5 pi over 6? Well, it happens to be exactly one of our points on the unit circle. 5 pi over 6 is in quadrant 2. For quadrant 2, we are going to do pi minus our angle. So this is in quadrant 2. So we calculate pi minus 5 pi over 6, and you get pi over 6. Okay. Now let's do negative 15 pi over 4. And I want to find a positive reference, a coterminal angle for it to make this easier. So I'm going to keep adding 2 pi over and over again until I find a positive angle. So, and remember that we can treat the pi as if it were a variable and just worry about the arithmetic part. So if I'm adding 2, I still have a negative value, and then if I add it again, I get 1/4. So this is coterminal with pi over 4. Okay? Now, pi over 4 is in quadrant 1. In quadrant 1, our reference angle is our angle. So our reference angle is pi over 4.